All right, so we've added polynomials, we've subtracted polynomials. Now we're going to get into kind of the next logical step, multiplying. The deal with multiplying monomials or binomials or polynomials in general is you have to pay careful attention to your exponents. Okay, before we use the exponents to kind of match up our terms and then add and subtract them, you don't have to do that when you multiply. When you multiply terms, you can multiply anything together. So they don't have to necessarily be matching for you to multiply, but the exponents get affected when you do multiplication because that's what exponents are for. I know I said this in a previous video, but just the idea of an exponent, forget algebra, forget variables. If you just look at what an exponent means, right, that 2 to the 5th power means that we're taking 5 2's and multiplying them together. That exponent is a shorthand for how many 2's you're multiplying together. Bring in a variable, and it means the exact same thing. So, excuse me, x to the 5th means whatever value x has, you've got 5 of those, multiplying them all together. Now, what some people tend to do, just I don't know if it's out of hastiness or just not paying attention, is they will take the exponent and the base and multiply them together and give the result as far as that goes. We're not doing any sort of evaluating with exponents, but just be aware that that's not what an exponent means. An exponent is telling you how many of the base you have to multiply together. One other thing just to kind of throw out there, and this is like 3rd grade. When you multiply things together, it doesn't matter what order you multiply them. There's this thing called the commutative property of multiplication. It basically says you can multiply things together in any order and get the same result. We're going to use that here in a minute, so just be aware of that. It also works with addition too, but specifically multiplication today. You're not adding or subtracting anything. So what I want you to do is just kind of stop and think for just a second. What did we just say those exponents meant? We're going to multiply together some expressions that have the same base. So in this case, the variable, and then, what happens when you look at those exponents. So I'm going to kind of make these first couple, I'm going to do it the long way just to show you guys the shortcut. And then from there on out, it's just basically going to be shortcut. So x to the 3rd power, make that go away. X to the 3rd power means we're multiplying 3 x's together. 1, 2, 3. Sorry for the gigantic dot there for the multiplication, but I couldn't make it any smaller. So I've got x to the 3rd power. And then, just to kind of illustrate what's going on here, I'm going to switch colors. And I've got x to the 6th power. So 2, 3, 4, 5, 6. Okay, so I've got x to the 3rd and x to the 6th. Those guys are being multiplied together. Well, if an exponent is just a shorthand for how many terms are being multiplied together, I can take this x to the 3rd and this x to the 6th and multiply them together and come up with a result that is a single x term, but then the exponent is going to change to show me how many is being multiplied together in total. So in this case, I've got 9. Well, I'm just going to kind of highlight something here. We'll come back and talk about it in a second when it's a little more obvious. If you see what's going on there, great. There's a super easy shortcut to take with this. But I want to throw this in here just because of the that commutative property that I talked about. So I've got 3x to the 4th, 2, 3, 4. And then I'm going to switch colors again just to kind of highlight the differences. 2, 1, 2, 3, 4, 5, 6. So I've got 3x to the 4th and 2x to the 6th being multiplied together. Now that commutative property says I can shuffle these things up in any order and multiply them. So that's what I'm going to do. Again, just the long way this time. I'm going to put my 3 and my 2 together. And then I've got a string of 5, 6, 7, 8, 9, 10 x's. I want to, the reason I did that is because I really want to show you and highlight that the coefficients, the 3 and the 2, they're still just being multiplied together. Even though they may not be side by side when you do these, coefficients are still just getting multiplied together. So my end result here is going to be a 6, and then I've got this string of 10 x's that I can shrink back down to a single x with an exponent of 10. And again, kind of drawing attention to these guys here. So before I show you, what do you think the shortcut is? This big thing here may not mean a whole lot to you, but what I want you to get out of this is right here. This is my short nickel version of it. If I'm multiplying two things together, the shortcut for that is to just take their exponents and add it together. Now, this is where you kind of have to pay attention to what's doing. And if you don't remember the rule, that's fine, because you can, expand this out and look at how many x's are and then put it back together anytime. But if the bases are the same, meaning that the variables are the same being multiplied together, you can really just multiply those together by adding the exponents, which is what happened. Excuse me, which is what happened here. X to the third and x to the sixth gave me an x to the ninth, because 3x's and 6 more x's added together is 9x's altogether. The only thing is exponents do not affect the coefficients, right? So like 3x to the fourth, that fourth power is only on the x. It's not on the third. That's something that I've seen people do this year, as a matter of fact. When we had exponents before, they would use the exponents on the coefficient. That exponent is only on the variable. Okay, so we're just going to do a few of these, and this is exactly what your homework looks like. So I'm just going to kind of highlight the things that I think are kind of more important than others here. X to the third and x to the fifth, again, you can write out that string of 8 x's and then condense it back down, but these should just be pretty straightforward, x to the 8th power. Now, this one here, there is a single n up here. Generally, a single variable won't have an exponent on it, but for our purposes, there is an understood exponent of 1 on there. So when you condense that down and kind of put it together with the others, you've got an n to the 8th power, 1 plus 5 plus 2. This one, 2 times 4, your coefficients are going to give you a new coefficient of 8, and then an x to the 8th power. Pay attention to your integers. A positive times a negative is going to give us a negative 12, but there's more than one variable here. Basically, do your variables one at a time. An x to the 5th and an x to the 2nd is going to give you an x to the 7th, and then the y's will give you a y to the 10th power. If you've got multiple variables, x's, y's, z's, whatever, in your answer's variables need to be in alphabetical order. Now, generally, they're going to be given to you in alphabetical order. So if you just kind of do them one at a time, your answer will automatically be in alphabetical order. But it's not outside the realm of possibility that you could have, B, C, A, and your answer needs to be in A, B, C. But negative 16, where'd my pen go? Negative 16, negative 16x to the 4th, y to the 7th. These really, math-wise, these aren't super hard. You just have to keep the rule straight that says, hey, I'm going to take these exponents and add them together. That's it, guys. Multiply 2 monomials together. You're giving me a more simplified single monomial for your answer.